أعوذ بالله من الشيطان الرجيم بسم الله الرحيم. Assalamu alaikum to everyone. Today we are going to start our lecture number 7, which will be related to the stress paths. Stress path is an important concept which we need to understand in the advanced soil mechanics. It provides basis for the critical state soil mechanics and the constitutive modeling. So first we will study the basic concepts, and we will also discuss idealized stress paths. Then we will move towards discussing various laboratory stress paths which we can obtain from various lab tests. Then we will discuss the field stress paths, that how we can relate the field and lab stress paths. At the end of our today's lecture, we are going to discuss the conclusions or the summary which we understand from the above topics. There are few symbols which we need to refresh our minds. If you remember, we can denote sigma 1 as sigma A or sigma vertical as well. There are different symbols which are used in different books, so you don't need to confuse them with others. So sigma 3 will be represented as sigma R or sigma H. And as you know that K naught, or the lateral earth pressure coefficient at rest condition, would be equal to sigma H divided by sigma V, or in terms of effective stresses, we can denote that as sigma prime H divided by sigma prime V. When we are talking about Kf, it means that the lateral earth pressure at failure will be the same as sigma prime H divided by sigma prime V, but it is denoted with the subscript F. Now we will start our lecture with a question that, for example, if you want to draw the Mohr circle or the stress path, sorry, if you want to draw a stress path for a consolidated undrained test which is conducted in axial compression loading condition, so how we will plot the stress path? Till now, we already know that we can easily plot the data from the triaxial test. If you want to plot the deviator stress versus axial strain response in consolidated undrained condition. Now the question we need to answer is, how about the stress path in consolidated undrained condition? For example, if we have consolidated it till a point sigma 3, or we can say P prime, a certain P prime value or a sigma 3 value, how we are going to plot the stress path in consolidated undrained condition. Wali, Daniel, Shabir,
हेलो सर, अस्सलाम वालेकुम।
वालेकुम सलाम।
सर, सर एक्चुअली हम ये करेंगे कि जो हमारे पास 3 जो स्ट्रेसेस होते हैं ना, उसका जो मीन है, तो उसको वैल्यू देते जाएँगे और देखेंगे कि वो फेल्योर तक कैसे जाता है। क्योंकि ये स्ट्रेस पाथ जो होता है पी और क्यू का ग्राफ होता है ना। तो
ओके
एक एक्सियल स्ट्रेस होता है, दूसरा तीनों का मीन होता है। तो इसको फिर स्ट्रेस पाथ का तो मेरे ख्याल में यही मतलब है कि हम उसको मतलब ये देखते हैं कि वो किस तरह फेल्योर तक किस तरह जाता है। अब जैसे अगर अनरेन टेस्ट है सी यू, तो एक तो इसका टोटल स्ट्रेस है वो तो सीधी लाइन होगी, लेकिन जो उसका इफेक्टिव है तो उसमें से चूंकि जब हम शेयरिंग करेंगे तो पोर वाटर प्रेशर राइज करेगा, तो वो फिर लेफ्ट साइड पे मतलब जाना चाहिए उसको, क्योंकि उससे पोर वाटर प्रेशर फैक्टर माइनस होगा।
अच्छा, चलें शबीर कहते हैं कि उसको लेफ्ट तरफ जाना चाहिए। ठीक है। वली, दानियाल, फहीम।
सर स्ट्रेस पाथ से मुराद ये होता है ना कि फर्ज करें हमारे साथ वो एक सैंपल पे 3 डायरेक्शन से लोड लग जाता है ना, मतलब एक्सियल लोड है, लेट ये जो सिग्मा 3 है, सिग्मा 2 है, सिग्मा 1 है, इनमें से हम एक की इफेक्ट मतलब एक को कांस्टेंट लेते हैं या दो को कांस्टेंट लेते हैं, ठीक है, और जो तीसरा है उनको वेरी करते हैं, ठीक है।
ओके
तीसरे की वजह जो तीसरा लोड है जब जिसको वेरी करते हैं इसकी वजह से सैंपल कैसे फेल होता है। अब जो तीसरा है उसको कांस्टेंट रखते हैं, सेकंड को हम जो है ना वो चेंज करते हैं, सेकंड से जो है ना सैंपल कैसे फेल होता है, मतलब हर एक ट्रेस का दूसरे ट्रेस को जब हम कांस्टेंट करें तो इसका कैसे इफेक्ट होता है सैंपल पे।
ओके। नाउ if you want to draw the consolidated undrained stress path, so how it will look like? हाँ वाली, ये कैसे दिखाई देगा, मतलब कैसे हम इसको प्लॉट कर सकते हैं? शबीर कह रहे हैं कि ये लेफ्टवर्ड मूव करेगा।
सर टोटल जो होगा सर, टोटल जो स्ट्रेस है ना, वो सीधी लाइन होनी चाहिए, ऊपर जाएगी। ठीक है सर। और जो
टोटल हमारे पास ये
ना, इस
टोटल
तरफ नहीं
स्ट्रेस।
सर,
ओके।
लेफ्ट लेफ्ट के ऊपर जाएगी सर।
अच्छा, लेफ्ट के ऊपर जाएगी।
हाँ, और सर जिस टाइम फिर शेयरिंग होगी तो शेयरिंग के दौरान चूंकि वाल्व बंद होता है सीयू टेस्ट में क्योंकि कंसंट्रेटेड अनड्रेन्ड है ना, तो फिर
ओके
वो उससे प्योर वाटर प्रेशर माइनस होता है, तो वो फिर लेफ्ट पे थोड़ा सा शिफ्ट करता है।
ओके ओके, सही है। ठीक है। और वली आप ऐड करना चाहते हैं इसमें? Anyone else wants to add that how we can plot QP or QP prime, 2D plot of a stress path? We touched a little bit about the stress paths in shear
सर
strength lectures as
सर
well.
इस तरह होगा कि पहले जो है ना मतलब स्ट्रेस पाथ 100 के लिए हॉरिजॉन्टल होगा, ठीक है, फिर जो है ना वो इंक्लाइंड होगा एट सम एंगल।
पहले हॉरिजॉन्टल होगा, फिर इंक्लाइंड होगा,
नहीं नहीं, ऊपर ऊपर इंक्लाइंड होगा।
ऊपर इंक्लाइंड होगा।
हाँ,
ठीक है। पहले हॉरिजॉन्टल क्यों होगा, फिर इंक्लाइंड क्यों होगा?
हाँ।
हाँ वाली, पहले हॉरिजॉन्टल क्यों होगा, फिर इंक्लाइंड क्यों होगा?
ये कि सर
सर मैं थोड़ा सा ऐड करना चाहता हूँ।
ओके।
सर सर जो स्ट्रेस पाथ है ना, इसका तो सिंपल मेरे ख्याल में मतलब ये है कि एक मोहर सर्कल होता है ना, जिसको वो फेल्योर लाइन टेंजेंट होती है, फेल्योर एनवेलप जिसको टेंजेंट होता है। तो हम पे जो पॉइंट सर आपने जिस तरह पी डैश शो किया हुआ है, तो इसके ऊपर हम सर मोहर सर्कल ड्रॉ करते हैं, जिससे आहिस्ता आहिस्ता स्ट्रेस ऊपर बढ़ता जाता है, और हम ऊपर जिधर वो है ना जिस पे फेल हो जाता है, फेल्योर एनवेलप के साथ टच करता है, तो फिर इनके जो पॉइंट्स हैं ना, वो टेंजेंट पॉइंट्स हर सर्कल के, वो हम ज्वाइन करते हैं, तो वो सर स्ट्रेस पाथ होता है।
अच्छा, now Shabir is saying that Moore's circle should also be drawn to get the stress paths. ओके, अगर हम कंसोलिडेटेड ड्रेन टेस्ट रन करते हैं तो उसका स्ट्रेस पाथ, देन हाउ वी कैन plot the stress path for consolidated drained condition?
सर उसमें चूंकि पोर वाटर प्रेशर डिसिपेट हो जाता है तो टोटल और इफेक्टिव स्ट्रेस की फिर सीधी इंक्लाइंड लाइन होगी, मतलब ऊपर इंक्लाइंड होगी टू सम एंगल विद द, जी सर इस तरह, क्योंकि उसमें पोर वाटर प्रेशर चूंकि डिसिपेट हो जाता है तो डेल्टा यू ज़ीरो होता है, तो इसलिए उसमें तो इतना ज़्यादा सर फर्क नहीं होना चाहिए मेरे ख्याल में सर।
Okay, now if I'm saying that if I want to draw a line like this, is it possible to go the stress path in this direction?
सर वो फिर यही है कि एक कंप्रेशन होती है, एक एक्सटेंशन होती है शायद, क्योंकि पी से नीचे आ रहे हैं ना, तो क्यू को हम क्या कर रहे हैं, नेगेटिव कर रहे हैं।
Okay, that's good. Now we have an excellent discussion on the stress path. So far we know that it is dependent upon the consolidated undrained condition and consolidated drained condition. So I would say that drainage will definitely affect the stress path. The loading, whether it's axial compression or extension, that will also affect the stress path. How about the stress history? For example, if we are having a loose sand or normally consolidated clay, and if we are having a dense sand or consolidated clays, what do you think that is going to affect the stress path or not?
जी सर, सर क्योंकि डेंस सैंड या ओवर कंसोलिडेटेड क्ले में डायलेशन होती है, क्योंकि वो
Okay, the stress
मतलब
history.
उसके पार्टिकल।
Good. Okay, so stress history will also affect the shape of the or the path of those stresses as well. Now, Shabir mentioned about the P prime. I have a question regarding the P prime. What is P prime and how we can calculate the P prime? If I can zoom in there, that would be good. Yeah, this is the question now.
सर ये तो सिग्मा 1 प्लस सिग्मा 2 प्लस सिग्मा 3 बाई मीन उसका तीनों स्ट्रेसेस का एवरेज नहीं होता सर?
Wali, one
हाँ,
or
ये आपने
two?
लिखा हुआ है बिल्कुल
सर ये टू, सर मतलब ये कंडीशन पे
सर।
डिपेंड
2
करता है ना सर, ये टू वाला सही इक्वेशन है जिसमें हम सिग्मा 2 इज इक्वल टू सिग्मा 3 लेते हैं तो 2 टाइम्स बन जाता है, सिग्मा 2 इज इक्वल टू सिग्मा 3 लेते हैं।
Anyone else?
सर असल
One
क्योंकि
or two
में ये
for?
होता है ना कि
आइसोट्रॉपिक होते हैं ना, सिंपल आइसोट्रॉपिकली कंसोलिडेट होते हैं ना
Okay.
एक्सियल ट्रेस।
ठीक है वली, हो गया, सही है. P prime. Wali is with two. Who is saying one
सर आई
is
एम आल्सो
correct?
विद।
Okay, you are going with the two as well. So Shabir
सर
is also
आई वांट
going.
टू गिव द रीजन। सर असल
Yes,
में ये होता है
please.
ना, जिस तरह ट्राइक जो सैंपल है ना, उस पे 6 डायरेक्शन से स्ट्रेसेस लग रहे होते हैं, ऊपर नीचे लेफ्ट राइट फ्रंट बैक। तो हम क्या कर लेते हैं, 3 स्ट्रेसेस है, सिग्मा 1 सिग्मा 2 और सिग्मा 3। तो 4 डायरेक्शन से जो वर्टिकल हॉरिजॉन्टल डायरेक्शन है, लेफ्ट राइट बैक और फ्रंट, उससे सिग्मा 3 लग रहा होता है और सिग्मा 1 ऊपर से लग रहा होता है। तो इसलिए सर मुझे ये सेकंड वाला ठीक लगता है सर।
Okay, good. Anyone else? Waqar, Fahim, Maz, Shahid. Halim, Hazrat Bilal, Wahidullah. Anyone? Yes, please.
सर ये टू नंबर तो सही है, लेकिन ये पहला जो है सर, इसके बारे में मैं कुछ ऐड करना चाहता हूँ। शायद मैंने कुछ पढ़ा है इस तरह के सर, कि अगर हमारे पास हम 2D एनालिसिस करते हैं, मतलब कि जब हम कहते हैं कि सर एक साइड पे इनफाइनाइट लेंथ है, जब हम न्यूमेरिकल मॉडलिंग करते हैं तो उसमें हम ये लेते हैं कि जब एक साइड पे हमारे साथ जो है सिग्मा 3 पे वो इनफाइनाइट लेंथ है, तो हम जब सरफेस एरिया या जो हम हमारे पास 2D एनालिसिस हम करते हैं, जब हम स्टिफनेस मैट्रिक्स बनाते हैं, तो उस कंडीशन में हम ये पहला वाला भी यूज़ करते हैं।
Excellent addition. So Fahim is saying that this is also possible. Wali and Shabir. Fahim is saying that this is also possible.
सर इस केस में तो ये है कि फिर इस तरह अगर हमारे पास कोई प्लेन स्ट्रेन कंडीशन हो, मींस 6 डायरेक्शन से 3 डायरेक्शन से स्ट्रेसेस ना लग रही हो, क्योंकि हम मीन ले रहे हैं ना असल में सर, ये जो नीचे वाला है ना, ये 3 स्ट्रेसेस का मीन है, तो ये तो हम 2 स्ट्रेसेस का मीन ले रहे हैं। तो फिर ये फहीम जो कह रहे हैं, तो इट माइट बी पॉसिबल कि एक डायरेक्शन को हम मतलब कुछ इस तरह एजम्पशंस हो कि उसको हम कांस्टेंट ले ले या वो एक दूसरे को कैंसिल आउट कर रहे हो, तो फिर शायद पॉसिबल है।
सर ये ना कि ये फहीम जो कह रहा है ना, इस सिचुएशन में भी हम डिवाइड बाई 3 करेंगे, अगर मतलब जो थर्ड डायरेक्शन इनफिनिट है तो फिर भी हम 3 करेंगे तब सही होगा।
Good point. Now let me draw something here, if I can. I was expecting a very yes/no answer, but we are going towards a good discussion here. So I will draw something. How about sigma 1 and how about sigma, I would say 3, and if I say sigma, let's suppose 2 here, which is acting all around this triaxial specimen. So what do you say that, how about the sigma 2 and 3, they are both equal? So if I write that and if I divide it by 2 instead of 3, because sigma 2 is already equal to sigma 3, so is it a reasonable assumption or not? And we can also compare that as a 2D problem as well. Basically, Fahim is saying that when we are calling a triaxial test, it's not a truly triaxial test. For the first time, we are saying that the triaxial test which we are hearing till now, it's not a truly triaxial test, it's a biaxial test, because this component is already equal to sigma 3. A true triaxial test would be something which will be having sigma 1 value, sigma 2 value different, and sigma 3 value different. Okay, so this is the MIT definition of the mean effective stress, and this is the Cambridge definition of the mean effective stress. And Lamb and Whitman, they performed and they gave the concepts of the stress paths in the geotechnical engineering. But Cambridge University, as you all know, that there are CAM-CLAY models there, constitutive models there. So they have also done lots of work in the critical state soil mechanics, Scaffold and Roth, Jeffrey Wood. So they call P prime, which is the mean effective stress, and they used the definition number 2, where Wali and Shabir were saying that this is the correct one. But I would say that this is also the correct definition of the P prime, but it depends that which definition you are going to use, if you are using the MIT definition or if you are using the Cambridge definition, because we are going to study that in our today's class. Okay, so let's start now our lecture, because that's an excellent basis to start our today's lecture. Now, till now, we know the states of stress at a point in equilibrium can be represented by Mohr circles. So these are the points. And sometimes it's convenient to represent those states of stress by a stress point which has the coordinate. For example, Q prime or Q and P prime. Now when you draw the Mohr circles, what we were doing till now, we will just draw a tangent and then we will find out the phi and C using the Mohr-Coulomb failure envelope, which we also studied during our undergrad. Now, what if we take these points, the peaks, and we also take the deviator stress sigma 1 prime minus sigma 3 prime divided by 2, which will give us the radius of that Mohr circle, and this is the center coordinate of that Mohr circle. Once we get these points, we can draw another line. If we call that line as the Mohr-Coulomb failure envelope, we can draw another line here, and that line we can call that as a modified failure envelope. Now the angle will be equal to phi, and we can call for the time being this angle as alpha. It will have an intercept m. In case of tau and sigma coordinate system, we can get the Mohr-Coulomb failure criteria or those lines there from those Mohr circles. But if we draw the peak of these Mohr circles, we will obtain a modified failure envelope, which we can also write in terms of an equation, which is here Q prime is equal to m plus p prime and tangent alpha. If you look closely, we can relate that to the Mohr-Coulomb failure envelope as well. Okay, now that is, some people call that as KF line as well, and that is the same K, which is the lateral earth pressure coefficient, which is related to horizontal and vertical stresses. If you are talking about the active condition, so So it's the active lateral earth pressure coefficient. If you are talking about the passive condition, it's the passive lateral earth pressure coefficient. If you are talking about the at rest condition, that would be K naught. And if you are talking about the Kf, that means that it can be in active condition or it can be in passive condition. Now, the definition of the stress path. Stress path is a 2D graphical plot representing theoretical and experimental relationship between two stress parameters, which are Q and P. It is the locus of stress points during loading and unloading condition, which we will explain in our today's class. It is a convenient way to visualize how stress changes during loading and how it approaches the failure state. As Wali and Shabir mentioned about that we are interested in how those stresses are changing and what path they are following till the failure is occurring. Now, it is a common practice to use stress invariance Q and P to plot the stress path. Now, the next question which comes into our mind will be that what are the different types of stress paths? So we are having effective stress path and we are having total stress path. And we will discuss that in greater detail in coming slides. Now, what is the importance of the stress path? Now, for an elastic material, the progression of stress during loading is known if we have those elastic parameters. E and mu are given, then we can find out the shear modulus and we can plot easily the elastic response. But if we want to find out the elastoplastic behavior, which is the case for soils, now we need to know the stress path, and the dependency of the stress path is on the soil type, stress history, drainage condition, and the loading sequence. For example, if we take the soil type for clays, for sands, for example, for normally consolidated clay, over consolidated clays, or even for loose sands, dense sands, the drainage condition is drained condition or it's undrained condition, loading sequence, which is compression or extension. So all these factors will definitely affect the stress path in a laboratory test. So we will start with the idealized stress path, and then we will move towards the laboratory conditions and then field condition. For example, in some textbooks, you will also find out plotting sigma prime A and sigma prime R, which are the axial effective stresses and radial effective stresses. And you perform few tests, I would say minimum 3 tests in either drain condition or undrained condition, and you will come up with 3 points and you will determine the modified failure line, and that line you can say KF line. We can also plot in Q P prime plane as well, and also the representation of the P prime is also given here. So if you perform a compression test, so you will get that KF line, and you can also perform at least 3 extension tests and you will come up with the KF line, P prime and Q, or Q prime is expanded. Usually people ignore prime on the Q because you can easily find out the deviator stress subtracting sigma prime A and minus sigma prime R, or it's independent of the pore water pressure. So that's why people usually avoid prime on Q. Okay, now as I mentioned earlier on, and Fahim mentioned about that as well, this is the MIT criteria. Few people, they also prefer to write S prime instead of P prime when they are using sigma A prime plus sigma R prime divided by 2, or sigma 1 prime plus sigma 3 prime divided by 2, and T for sigma A prime minus sigma R prime divided by 2. So we can also write in terms of T and S prime just to differentiate between that P prime two definitions.
Excuse me,
Yes,
sir.
please. Yes, please.
Sorry, sir, I have missed the discussion due to internet problem, due to for the MIT and the Cambridge, this thing which we are discussing. So, sir, in my view, I think the MIT criteria is the reduced form of the Cambridge criteria, because in this case, I think we are assuming that sigma 2 from like it is cancelling out due to some means. Sir, am I right?
Yes, that is sigma 2, which is equal to sigma 3. So therefore, they are taking because as you already know that in triaxial apparatus, which we know till now, sigma 2 is basically equal to sigma 3.
Yes.
Agree?
Yes.
So
Indeed, sir.
therefore, you can just take sigma 1 and sigma 3, you can divide it by 2, and that's Lamb and Whitman, they worked on that in Massachusetts Institute of Technology. So they use this criteria or this definition for the P prime. Now, in Cambridge University, as I mentioned earlier on, if you have missed that, Scofield Roth and Jeffrey Wood, those people, they were working on developing constitutive models, and they used this definition of P prime. And few people also denote that as S prime and T as well, just to differentiate between those two definitions. Now, the idealized situation. Let's go and
सर
plot. Yes, please.
सर सर पिछले स्लाइड पे सर आप जाए सर सर यहाँ पे जो टी है इसका एवरेज क्यों लिया गया है सर
Sigma 1 prime minus sigma 3 prime divided by 2. This will give us the radius of that Mohr circle. And that can be assumed in case of, I would say, in case of unconfined compression test. Agree, Fahim, or not?
नो आइडिया सर
Good point. That is also a good question.
सर मैं थोड़ा सा इनके लिए इजी करूं.
Yes,
सर
please.
आपने अभी अनकन्फाइंड का जिक्र किया है ना, तो अभी अगर हम टी को देखें, अगर हम ये बोलते हैं ना कि सिग्मा ए माइनस सिग्मा आर जो है बाई 2 ये मोर सर्कल का रेडियस है, सर अनकन्फाइंड में हम क्या करते हैं, सिग्मा आर जो होता है वो 0 होता है, तो इसलिए वो डायरेक्ट क्या हो जाता है, सिग्मा ए बाई 2. तो वही बात है सर, एक्चुअली दिस इज द मोर सर्कल रेडियस.
Yeah, that's the definition of Q. That's what I have taken it from the definition of Q and definition of P. Okay, so this would be the radius of the Mohr circle. Now let's go for the idealized stress paths. For example, if we are plotting T and S S prime plot, this is the isotropic line. In isotropic line, for example, if we are plotting that as S prime and we are performing a consolidation test, so from consolidation test we are starting with 0 horizontal and 0 vertical stresses, and if we are moving from this point till this point, we are having any confining pressure, what would be the value of K, or the lateral earth pressure coefficient? In an isotropic line, what would be the value of K? वली K क्या होगी? शबीर,
सर 1 नहीं होगी?
के सर एस के बराबर होगी इस सिचुएशन में।
किसके बराबर? हाँ वली, हमारे पास K क्या होगी?
सर यूजुअली तो सिग्मा 3 डिवाइड बाई सिग्मा 1 के बराबर होता है।
तो K की वैल्यू क्या होगी आइसोट्रोपिक लाइन पे? किस लाइन पे?
नहीं सर, आइसोट्रोपिक का मतलब ये है कि हर डायरेक्शन से उस पे स्ट्रेसेस सेम है।
वो 1 के बराबर होगी 1।
ओके, हमारे पास 1 के बराबर होगी। तो ड्यूरिंग द कंसोलिडेशन स्टेज हमारे पास, अगर आप देखें तो ये हमारे पास स्ट्रेस पाथ जो मूव कर रहा है वो K इज इक्वल टू 1, उसका स्लोप जो है ना वो क्या होगा? 0 होगा। अब अगर हमारे पास एक सिचुएशन ऐसी होती है, नाउ वी आर कंसिडरिंग ए सिचुएशन दैट in the field we are changing delta sigma prime A, or I would say that delta sigma prime A is also changing, and delta sigma or sigma prime R is also changing with the value of delta sigma prime A. Now in that case, how it's gonna change? So this was the slope of the first case is here. Now if we are assuming that sigma R is 0 or sigma prime R is 0, in that case delta T prime or delta S prime, please don't confuse that with the denotation. I can write that as delta Q divided by delta P prime as well. But here the definition will be different, okay? You need to note down that the definition of the Q will remain same, but the P prime will change because the slopes would be different. So if you are going for the stress path, and I'm again repeating that these are the idealized stress path conditions, we are going to discuss the lab and field, only then you are going to understand what we are really drawing here or what really plotting here. So for this case is the consolidation behavior, and then in drained condition or in condition in which the sigma prime r remains equal to 0, that would be delta sigma prime r, which will be equal to 0, and it will reach to a prime b prime. So it will follow a stress path in such a way that the stresses are changing as we are loading this specimen in drained condition. Now there might be also a situation which is a b prime and c situation, where the delta sigma a and delta sigma r will be equal to the pore water pressure. Now in such a situation, the stress path will only increase the delta u. So these are the idealized situation, as I mentioned. So the stress path will vary based upon the pore water pressure and the drainage condition. Similarly, we can also plot that if we perform an extension test, the stress path will go down, or if we decrease the sigma A, or the change in axial stress is equal to 0, the stress path or the slope of the stress path will vary and it will decrease. Now in terms of the Cambridge plots, if we are coming, we can also plot that in Q and P plane as well. And similarly, we can see that in the consolidation stage, delta Q and delta P prime would be equal to 0. So if we are drawing the stress path for the consolidation in the isotropic consolidation environment, it will be a flat line and it will lie on the hydrostatic plane, or we can call that as P prime plane. Now if we again repeat the same stresses condition, for example, if we are having change in delta sigma r is 0, then delta q divided by delta p prime, which usually occurs that in the drained condition, then it will increase at a slope of 1:3, or a prime and b prime will give us the stress path for that particular loading condition. Now if we again assume that delta sigma A is equal to delta U, or delta sigma R is equal to delta U, now in that case delta P would be equal to delta U, which is represented by delta U from B prime and C stress path, and delta Q divided by delta P prime would be equal to 0. So we will experience and see a flat idealized stress path. And similarly, if we change the stresses condition and the loading condition, we are going to experience a different stress path, which will decrease from B prime till C prime point. Now, what's the importance of finding, the stress path? For example, if we are doing a consolidation test here, and if we are performing a drain test here, and if we are performing an undrained test here, or if we are decreasing the delta sigma A, or it's 0, okay, or if the stress path in going in this direction, or if it's going in this direction, or if it's going in this direction, what is the importance of finding the stress path? Main thing is that we need to find out the failure line. We need to reach to that failure line so we can plot the data in drained condition, and we can also plot the data in undrained condition. For example, if you are talking about the effective stresses, we can plot the data for different sigma A and sigma A prime, sigma R, or sigma R prime. You can plot that data as well. So these are very simple way is shown in here, that how we can plot the stress paths. In reality, or I would say, in lab, I will show you, it looks totally different. This one looks a bit close to the stress path which we obtained in the trained loading condition. So we can plot those S and T plots are Q and P as well, based upon that definition of MIT and Cambridge. Again, if you are talking about the undrained and drained condition, so we can plot different stress or QP plots. Now, what is the relevance of the stress path plots? Locus of stress point is not relevant unless the bounds are defined. Now, if we plot these, we need to define the bounds, or I would say the failure lines. Only then we are going to get the benefit of the stress paths. Now, failure can occur in compression, and it can also occur in extension loading as well. Now, if we remember from the Mohr-Coulomb failure criteria that sigma 1 prime and sigma 3 prime are related using this equation, and if we assume that C prime is equal to 0, then you can write this simplified equation. And if you want to compare the stress ratios, now what is Kf or K? It's basically the sigma 3 by sigma 1, which is a stress ratio. So if we compare those stress ratio, we can find out the failure line or Kf in compression loading, and we can also compare that failure line in extension loading. Now, if you want to plot the sigma A or sigma prime A or sigma R or sigma prime R, then this would be the isotropic line, and here the slope will show us we can find out the slope of the Kf in compression loading would be tangent square 45 plus phi prime divided by 2, and the slope in the extension loading will be equal to cotangent square 45 plus phi prime divided by 2. Now we got two boundary lines, or the failure lines, for the stress path in compression and extension loading. Similarly, if you want to plot that as in T and S prime plane, the slope of this failure line would be equal to sine phi prime, and the extension loading, it will be minus sine phi prime. So this line shows the Kf in compression, and this line shows Kf in extension. Now, in reality, when you are performing those tests, so you can not obtain exactly same alpha when you are performing extension test in triaxial. And there is a reason, because in compression the soil can take more load compared to in extension loading. So therefore this angle is much smaller. This alpha is much smaller than the alpha in the compression loading. Now, if we are going to plot the data in QP and QP prime plane, then we will find out a slope which is equal to 6 sine phi prime 3 minus sine phi prime, and that m is known as the slope of the critical state line, which we will discuss in the critical state soil mechanics lectures. And if you want to find out the slope in case of the extension loading conditions, which means that we are increasing the lateral pressures or we are increasing the load in extension, then we can also find out the slopes in those conditions. Now, here it's shown that how you can relate the stress path information with finding the shear strength parameters C prime and phi prime. For example, if we are given with, if you find out the alpha and m, you can find out the effective friction angle and the effective cohesion. Now let's assume that we applied a sigma on, and we have this is sigma 1, this is sigma 3, and now we are reducing that sigma 3 now. Initially the peak point was here, and then it reached here, and then it reached here, and then we reached to that particular peak here, and this is the Mohr Coulomb failure envelope. Okay, this is the Mohr Coulomb failure envelope, and here it's the KF line, or the modified failure envelope, which we got from the Q and P prime plane. So if you draw a line something like this and reach to that failure line, this will be known as the stress path. Now, stress path in a consolidated drain test, as we discussed in our start of the lecture, that in the drained loading we will reach to a Mohr circle here, and then if we further increase the loading, it will further increase and the Mohr circle size will increase. Again, if we further increase the loading, then the size of the Mohr circle will increase, which means that it will reach to a deviator stress at failure. Okay. And that will lie on the KF line. And that is the Mohr Coulomb failure envelope or line. Now, how about the stress paths in a consolidated undrained test? Or I can put in another way as well. For example, this is the total stress path, which will be drawn at a 45-degree angle. Now, if we want to draw the stress path of the effective stress path, it will move leftwards and it will reach to the failure line. But I have a question about the normally consolidated clays and also loose sands. And I would say over consolidated clays and dense sands. This figure is for case 1 or case 2.
सर मैं आंसर करूं या कोई और करेगा सर?
नहीं, थोड़ा वेट कर लें, थोड़ा जब कोई आंसर नहीं कर पा रहा तो फिर जो है ना आप वहां पे जंप कर सकते हैं. This plot shows the behavior or the stress path for normally consolidated clays or over consolidated clays. And why?
मेरे ख्याल में मैं आंसर कर देता हूं.
वली को मौका देंगे. वली मौजूद है कि नहीं? फहीम प्लीज काइंडली आप अटेंडेंस ले लें. फहीम, शाहिद, हलीम, हजरत बिलाल, किफायतुल्लाह, माज, शबीर, सैयद वकार, यूनस, वहीदुल्लाह. वली तो है ही नहीं मेरा ख्याल. दानियाल है, सुमेर, चलें आप बता दें प्लीज.
अच्छा सर, ये फर्स्ट केस के लिए, क्योंकि सर इसमें हो ही रहा है ना कि जो पोर वाटर प्रेशर है नॉर्मली कंसोलिडेटेड क्लेज में और लूज सैंड में, तो उसमें पॉजिटिव पोर वाटर प्रेशर होता है, तो इसलिए सर वो उससे माइनस हो रहा है ना टोटल स्ट्रेस से, इसलिए वो लेफ्ट पे जा रहा है. अब अगर ओवर कंसोलिडेटेड क्ले होगा तो ये जो डेल्टा यू डी है ये पॉजिटिव नेगेटिव होगा, तो वो नेगेटिव इंटू नेगेटिव वो पॉजिटिव हो जाएगा, तो वो फिर राइट पे जाएगा.
Okay, good. Thank you very much, Shabir. Now for the contractive clays, for contractive soils, are normally consolidated clays are loose sands, so you will see that it will develop positive pore water pressure, and that positive pore water pressure will decrease the effective stresses, so therefore the P prime will reduce. And when we are dealing with the dilative soils, or we can say the over consolidated clays, dense sands, or cemented sands, this stress path moves towards right side, and it will, if I want to plot, I don't want to plot it here, but let's see if I can plot it here, something like this, and it will reach to that failure at greater deviator stress. So you can clearly see that for loose sands or normally consolidated clays, the difference in the deviator stress can also be seen here from this plot. And if you draw the total stress path, so it's simply 1:3. else? Yes. Now, when we want to compare the A parameter, this is the Skempton A parameter. For example, if the A parameter is less than 0, so the stress path would lie in this region. And if the A bar or A parameter is equal to 0, which means the drained condition, that will be drawn something like this. Now for ore consolidated clays, as I mentioned earlier on, that the AF parameter, sorry, this is the in between here, AF parameter should be in negative, but let's see, this one is for normally consolidated clays, A bar is equal to approximately 0.5 and A bar is equal to 1, then the stress path will follow this direction, and the discussion on the delta U and the contractive soil or the dilative soil is also presented here. And if you want to find out the A bar, which is delta U divided by delta sigma D, so mainly if we want to draw a line, so this portion would be for the contractive soils or normally consolidated clays or loose sand, and this portion or in this region is for the over consolidated clays or dense sands. Yeah, negative one is also here. So if it's heavily over consolidated clays, here we will find out the negative A bar, which means that it will reach at significant KF line, or even if it won't reach to that failure line as well. Only today is Sunday.
बोली busy सर के Sunday को Monday सर.
Okay, so here is another example. Okay, let me say that as well. Location and path of the effective stress path corresponds directly to A bar. So the location and the path of the stress path, or the effective stress path, would depend upon the Skempton A parameter. Now, in order to reach to that failure, effective stress path information is very, very important compared to the total stress path. Now, we will discuss a practical example showing that how the stress path the soil is following. I don't know if you can read from that slide. So stress path of sedimented soils in the field and sampled soils. So now it's giving you an idea that why the stress path is going to be important. So Shabir, if you can please kindly read it sentence by sentence, I think it would be helpful for all the other students as well. Shabir. Daniel, Fahim.
Yes, sir. When soils are deposited in a sedimentary environment like a lake or the sea, there is a gradual buildup of overburden stress as additional material is deposited from above. As this stress increases, the sediments consolidate and decrease in volume. If the area of deposition is relatively large compared with the thickness of the deposit, then it seems reasonable that compression is essentially one-dimensional. In this case, the stress ratio would be constant and equal to K naught, and the stress path during sedimentation and consolidation would be similar to path AB in figure 10.21. Typically, typical values of K naught for gradual materials range from about zero point 0.4 to zero point 0.6, whereas for normally consolidated clays, K naught can be little less than zero point 0.5 up to zero point 0.8 or zero point 0.9. A good average value is about zero point 0.5.
Thank you,
Now,
Fahim. Thank
soils.
you. Thank you. Thank you. Yeah, you can stop there. Now, as the sedimentation and consolidation is occurring, the stress path for that particular soil would show if you are drawing or if you are plotting it in QP prime plane. So from A to B would give us the sedimentation and consolidation steps. Now for what we do as a geotechnical engineer, now we do the sampling. We collect samples from there. So anyone else except Fahim can read from this till here. That what is happening after A to B is the sedimentation and consolidation process. Now, what will happen from B to C in the sampling? So anyone else who is present there?
Assalamu alaikum, sir.
Wa alaikum salam, Wahid. Yes, please. So you can read from when a sample of soil is taken, what happens now?
When a sample of soil is taken, stress decrease occurs because the overburden stress has to be removed to get at the sample. The stress path follows approximately line BC in figure 10.21, and the soil specimen ends up someplace on the.
Okay, thank you very much, Wahid. Now, here we will collect the sample from B to C. This is the sampling stage. But in some cases, this overburden pressure can also be removed and it can reach to a stage below that P prime level. Now in that case, due to the erosion or some geological process, so if you are saying that this is K equal to 1, and if you are saying that K naught is recommended for normally consolidated clays is equal to 0.5. Now if you are taking a point below K equal to 1, it means that we are in the over consolidated clay range, and that would be over consolidated clay in which the horizontal stresses would be greater than the vertical stresses. Now, different lab tests which corresponds to different stress paths. Now, for example, if we consolidate our specimen to a certain sigma 3, now it can go in this direction, or it can go in this direction, or it can go in this direction, depending upon the stresses which are applied onto that soil. So for example, if sigma V is taken and sigma H is also applied, now if we increase or decrease delta sigma H, that will decide the stress path that soil is going to take. And in the lab, now how we can relate these conditions to the field will be discussed in the coming slides as well. Now, for example, K is 1 here, is the isotropic consolidation stage, and in this region the sigma H changes from sigma 3 to sigma 1, which means that sigma horizontal would be greater than the vertical one. These are the different stress paths which can be attained in lab. For example, this is the stress path which shows the isotropic consolidation stage. There is another condition in which delta sigma H is equal to half of the delta sigma V. It will follow this stress path, and if this is the consolidated drained condition stress path, now if there is a situation where delta sigma H is equal to negative delta sigma V, if I write clearly, now in that case the Mohr circle will take the form in such a way, and the stress path will move upwards in straight direction. And this stress path will be the stress path of the direct simple shear apparatus. Now, if a situation occurs that delta sigma H increases, and we will show you that how delta sigma H increases and delta sigma V decreases, which can occur in retaining wall in active condition. So you can draw the Mohr circles and you can get the stress path, and we can reach to a failure line as well. And that failure line is known as critical state line, which we will discuss in our coming lectures when we relate the volumetric changes to that as well. Now, if delta sigma H increases and delta sigma V decreases, now in that case the Mohr circle will be drawn in such a way, and you can draw the stress paths in this direction. Now, till now we were talking about the stress paths. For example, it can go in this direction, or it can go in this direction, or it can go in this direction. Now you can clearly see that we are starting the shearing stage from the hydrostatic line or the isotropic line. But what if there is an anisotropic condition, where there is a certain Q is applied in the field and certain P prime is also applied, and then we are going to start the shearing stage. So the consolidation is occurring at an anisotropic condition. Now what will happen? So the stress path will also depend upon the anisotropic condition, and that is what is explained here, that if we are having an anisotropic condition where we are starting, for example, here it's K, I think so, I have drawn somewhere there, yeah. If K is equal to 1, so this is the isotropic consolidation stage, and if K is less than 1, this will be this condition, and if K is equal to 0.5, this will be for the normally consolidated Clay's condition. So the stress path can start from an isotropic consolidation stage as well, and this is for the compression condition, and this is for the extension condition. Now various delta sigma V and delta sigma H situations and their respective stress paths are also plotted here. In sigma 1, and if K is less than 1, and then we will have a Kf at which the failure will occur. You can find out that. Now, this is the summary of the stress paths for drained loading. So the direction of the stress path is dependent upon the type of loading. Okay, so this is the first point which you need to note down. For drained loading, total stress path is equal to the effective stress path. This is another important point which you need to note down. Now we are moving towards the practical field applications. Now for practical field applications, the axial compression will give us this stress path will be related to the foundation loading. And lateral extension, this stress path would be related to the active Now for the axial extension, this stress path will be related to the unloading or excavation condition. Now how about the lateral compression? This would be the passive earth pressure condition. Now the stress path for drained compression with initial pore water pressure. For example, if we draw a plot here, now this is the effective stress path and this is the total stress path, and as I mentioned earlier on that the slope would be 1:3, and here is the Kf or the failure line which corresponds to the critical state. Now we haven't talked anything about the volumetric changes yet, that's why I don't want to use the word critical state here because we will move towards a different definition, but a state will be reached That's why I was trying to call that as the modified failure envelope. But the term has been used here, so I think it's just creating a basis for the critical state soil mechanics. So if you draw the total stress path and the effective stress path for various tests, we can reach to that point. And why the effective stress path went beyond the KF line? Because if you see for dense sands, you will reach to the peak point and then you will reach to the critical state. So this is the peak of the stress strain behavior in dense or over consolidated clays, and that's the peak which is represented here, and that's the critical state which is represented here. Now if you want to draw the effective stress path and the total stress path, that difference would be the U naught or the back pressure. Now typical stress paths for undrained loading. For normally consolidated clays or loose sand, you will experience A bar, or the Skempton pore water pressure parameter, would be less than 0, and the pore water pressure would be positive during the shearing stage. How about delta sigma prime relative to delta sigma? It will increase, the effective stresses will decrease because the pore water pressure are positive, so the effective stresses will reduce. Now how about the dense sand and highly over consolidated clays? So the A prime or A bar F would be less than 0, and the pore water pressure would be in negative. So if it's negative, this will increase. If this is decreasing, we talked about the stress path for the normally consolidated clays. So this would be for normally consolidated clays or loose sands, and this will be equal to the dense sands or over consolidated clays. For anisotropic condition, because this is the isotropic condition, for anisotropic condition where K naught is less than 1, if you want to plot the stress path or the effective stress path, it will look like this, and it will reach to a failure line KF. And if you want to draw the total stress path in axial compression mode, and that difference would be the delta U, the change in the pore water pressure, in plotting the total stress path and the effective stress path. Same explanation is also given here. If you want to draw the total stress path or the effective stress path, that difference between the total stress path and the effective stress path, that is the change in the pore water pressure. Here you can plot KF line if you are talking about the TSS prime. Okay. You can find out the slopes for total stress path and for the effective stress path in case of drained and undrained condition. Similar explanation. Yes, here if you see, this is the total stress path, and this is the, for example, total stress path, but the effective stress path will change something like this. and it will reach to the modified failure line here. Now you can see clearly that this portion will be related to this portion of the positive pore water pressure, and this portion will be related to the negative pore water pressure. Okay, and this initial difference between the total stress path and the effective stress path is U naught or equal to the back pressure. That explanation is also provided here, that for highly over-consolidated clays, you will have a negative pore water pressure and the effective stress will increase. And that you can clearly see that if we were having a normally consolidated clay, it would have been reached to the failure at a much lower level of Q. But here you can see that at much higher level of Q, this over consolidated clay or dense sand has been failed or reached to that critical state. Other stress paths can also be drawn at various A values or Skimpton A parameters. That explanation has already been done. Now, how about the field loading? Shabir, Wali, Fahim, anyone else? Shahid. Halim Mullah Khan, Hazrat Bilal. Field conditions. Waliullah, are you there? So these are the different field conditions. For example, axial compression condition, axial extension condition, the stress path, how we can draw the stress path. For axial compression, the stress path will look like this.
zoom कर ले सर.
Okay. For foundation loading, if you are having an embankment and if you want to draw the stress path in axial compression loading condition, it will look like this. Now, if we are having a soil specimen on which the delta, the sigma V, or the overburden pressure has been released, now in that case, the stress path will look like this, and it will refer to the axial extension condition. Now we are having another scenario where the active earth pressure condition is there. Now in that case, it will look like the stress path will look like the stress path in the lateral extension condition. Now if we are having an anchor there and this retaining wall is pushed into the soil, now in that case the stress path will look like this, which is the lateral compression condition. Similarly, various explanations are given for the soil elements beneath the embankment and a bit far from that embankment. For case A and case B, delta sigma A and delta sigma R are also provided, and the ratios are also given delta T divided by delta S to find out the slope of those stress paths. Now, in a slope condition, the two samples you can collect from point C and point D, and we can also find out the lateral stresses and the axial stresses and delta T divided by delta S. So how we can plot these stress path in the field conditions can also be seen here, and the practical application of those stress paths in foundation loading, in foundation unloading or excavation. And if I say this is the foundation loading, foundation unloading or excavation, and this is the earth pressure, active earth pressure, I would say active earth pressure condition, and this would be the passive earth pressure condition. So the application and the practical application of the stress path is explained in these slides. Now, the undrained effective stress path will depend upon the characteristic of the soil, stress history, and manner in which the stress changes or the loading, which we discussed in our previous slides. Now, in summary, stress path is the graphical representation, or if someone can help me with reading out the summary, that would be great. I will take some water.
Stress path is the graphical representation of any two stress parameters. It is a convenient method to trace the progression of stresses during loading and how it approaches towards failure. Stress path can be effective stress path or total stress path. Stress path is a function of soil type, stress history, drainage, and loading sequence. Different stress parameters can be used for plotting stress paths. It is a common practice to use stress invariants for plotting stress path. Plotting of stress path in terms of sigma A, sigma prime A, sigma R, and sigma R prime, T, S, S prime, Q, P, or P prime demonstrate for simple stress variations.
Now, the stress path is
Stress
meaningful. Please, thank you very much. Okay. The stress path is meaningful only if the bounds are defined. Now, you cannot say that, okay, we know that how we can draw the stress path, but bound is important, and that what we discussed in the failure line, or we call that as a modified failure line, and we might call that as a critical state line when we compare that with the volumetric changes. So the bounds are defined in terms of the failure lines, and failure lines are determined by these parameters, which depends upon the different definition of the P prime, which are used like the MIT or the Cambridge definition for the P prime. Okay, now the final word on the stress paths from Dr. Bob Holz. Very often in geotechnical practice, if you understand the complete stress path of your problem, you are well along the way towards developing a solution for that problem, which simply means that if you idealized, imagine, or you can estimate the stress path for that particular problem, and you can bring it to the lab, and then you test that in particular condition which will occur in the field, and you find out the shear strength parameters and you put it into your numerical model, then you will again get a response, stress strain response, stress path response there. So you can estimate those shear strength parameters, or you can estimate the settlement behavior or the stability of those geotechnical structures. So if you read it again, you will know that very often in geotechnical practice, if you understand the complete stress path, whether this stress path, let me clear out that if I can. Shabir Daniel Wali Wakar, are you there? Halim Hazrat Bilal,
Yes, sir.
who is there? Yes sir, किसने बोला है?
Wakar Yunus, sir.
अच्छा वकार, ये बताएं कि हम सैंपल लेते हैं, जाते हैं, ठीक है, एक जगह से सैंपल लेते हैं, दूसरी जगह से सैंपल लेते हैं और तीसरी जगह से सैंपल लेते हैं, ठीक है, फिर हम आते हैं, कहते हैं कि यार यहाँ पे हमने 50 किलो पास्कल, 100 किलो पास्कल, 200 किलो पास्कल, इस पे हमने टेस्ट रन करना है, ठीक है। तो ये कौन सा स्ट्रेस पाथ हमें प्रोवाइड कर रहा है, और यहाँ से हम जो कोहेजन एंड फ्रिक्शन एंगल लेते हैं, चले हमने कंसोलिडेटेड अनड्रेन्ड किया या कंसोलिडेटेड ड्रेन्ड भी किया, तो किस कंडीशन के लिए कौन सी स्ट्रेंथ हम लेंगे, एंड फॉर हिम यू कैन आल्सो contribute in that discussion, that which shear strength will we are going to use in the numerical modeling. If you are, for example, modeling an embankment, or if you are dealing an excavation problem, if you are dealing a retaining wall problem, or if you are having a passive earth pressure situation in the field, which strength we are going to use and how we are going to approach in our lab. चल सारे जो है ना इसमें डिस्कशन में थोड़ा सा पार्टिसिपेट कर लें। क्वेश्चन ये है ना कि अगर हम देखते हैं तो हम सैंपल लेके आते हैं, डायरेक्ट शेयर में टेस्ट में रखते हैं, वहां से हम सी एंड फी निकाल लेते हैं, ठीक है। हमने फिर शेयर स्ट्रेंथ में कहा कि एडवांस जो टेक्निकल अपरेटिस मौजूद है उसमें ट्राइक्सियल अपरेटिस है, सिंपल शेयर डिवाइस है, ठीक है, वहां से हम शेयर स्ट्रेंथ फाइंड कर सकते हैं। फिर हमने कहा कि हम फील्ड में भी फाइंड कर सकते हैं। अभी हम ये कह रहे हैं कि यहाँ पे स्ट्रेस पाथ इंपॉर्टेंट है। स्ट्रेस पाथ क्यों इंपॉर्टेंट है? क्योंकि सिर्फ सैंपल कलेक्शन और सिंपल एडवांस जो टेक्निकल टेस्टिंग नहीं, उसमें स्ट्रेस पाथ की इंफॉर्मेशन भी हमारे पास होनी चाहिए कि ये सॉइल स्पेसिमेन या ये सॉइल किस पाथ पे जो है ना वो फेल होगा। आइए समझ के नहीं है उस पे स्ट्रेस कंडीशंस कौन कौन सी होंगी, कैसे वो फेलियर तक रीच करेगा। कार समझ आई है कि नहीं आई कि ये मुश्किल सब्जेक्ट है या टॉपिक है? Okay, so we will move towards our question and answer session. Additional reading is also provided there. So if someone is interested in further reading, they can read. And if you are having any question, we will move towards our question and answer session. Thank you very much for your kind participation. Assalamu alaikum. and Allah Hafiz.